Sure. So let us begin with today's class. The groundwater management first. Okay, groundwater management. Then groundwater provinces in Maharashtra. Okay, groundwater provinces in Maharashtra. Then groundwater legislation. Okay, groundwater legislation and groundwater auditing and budgeting. These are the four topics. Okay, four topics which we have to cover. Not in today's class, but yes, in one or two classes. Right. So I'll try to cover as much as possible, right? So let us start with the groundwater management first, right? The groundwater and management, technical and community aspects. Okay, this is the topic. Okay. Okay, is this screen visible?
Yes, sir.
Yes.
So the groundwater management. Okay, groundwater management. Now, the groundwater management is to protect the aquifer from over exploitation, right? Over exploitation means what we are actually doing. Okay, what we are actually doing, what, how much water do we need? Okay, earlier you might have heard or you might have seen if you have individual homes. Okay, if you have the individual homes, there used to be a dug well. Okay, there used to be a dug well. Now, what is this dug well? A smaller well. Okay, a smaller well, usually of 40 to 50 feet. Okay, usually of depth, right? The depth of 40 to 50 feet, and it used to have water, and there used to be a pulley so that you can pull out the water, right? So these dug wells, okay, these dug wells, they helped recover water. Okay, they help recover water in a smaller quantities. Okay, in a smaller quantities, because every time you had to put the bucket in and then drag water outside, right? But with the advent of or with the invention of the machines, okay, the machines and borewells, okay, with the borewells and machines, what we have done, okay, what we have done
Kusho,
is that the borewells have penetrated deep aquifers. Okay, they have penetrated the deep aquifers, and these and we have started exploiting, or we have started taking out more and more water. Okay, even more than the need. Okay, even more than the need. Okay, so this is the problem of over exploitation. Okay, this is the problem of over exploitation, that whatever is your need, you are exploiting, or you are taking out more than that, right? You are taking out more than that, right? So that is called as over exploitation. Now, to overcome this problem, we have significantly destroyed the groundwater resources in our country itself, right? India is third largest. Okay, India is third largest in consumption of groundwater, right? India is third largest in consumption of groundwater. So we have done the significant damage for these groundwater resources. Now, to overcome this problem, okay, to overcome this problem, what we have to do, we have to go for effective groundwater management policy, right? We have to go for effective groundwater management policy. We have to manage the groundwater in such a way that more and more groundwater to be sustained, more and more groundwater shall be remain where it is, right? It is not exploiting, it is not getting extensively used, right? So oriented towards promotion of efficiency, equity and sustainability, which is required, right? Now, agricultural holdings in India highly fragmented and rural population density is large. Majority of the times for agriculture, if you see, okay, for agriculture, if you see, nowadays, earlier days, the agriculture used to be based on the rainwater itself. Okay, only the rainwater. But now agriculture is majority based on the groundwater. Okay, it is majority based on the groundwater. Each and every farmer has large capacity pumps. Okay, they have these pumps, and they pull out water as much in as quantity as much they can through this pump. Okay, and they just spread out these water on their fields, right? So these agricultural holdings, they are actually fragmented. No farmer in India, okay, or very few farmers in India, they have larger lands or one complete complete land in particular area. Okay, majority of the farmers have uh, fragmented lands, right? They have the fragmented lands, they have patches of lands spread over a large area, right? So it is a problem. Okay, this is a problem that these recharge possibilities, okay, these recharge possibilities from the fields is a bit different, okay, or difficult, right? So the detrimental environment consequences of over exploitation need to be effectively prevented by the center and state governments. Okay, so it should be done by the central government, it should be done by the state government, right? It is more responsibility of a state government. Okay, more the responsibility of state government. Why is it so? Why is it so? Because water, okay, water is a state subject. Okay, water is a state subject. There are three lists. Okay, there are three lists which are central list, state list, and concurrent list, right? Central list, state list, and concurrent list. So these three lists are there. According to these three lists, some subjects are given to central government, some subjects are given to state government, and several subjects are put in a common list which can be addressed by central government as well as state government, right? But the water is completely a state subject. Okay, water is completely a state subject. So the central government, right, the central government should act for or should go for effective prevention. Okay, effective prevention of this over exploitation of the groundwater, right? Over exploitation of groundwater and proper management of the groundwater, right? Proper management of the groundwater. But only government is not responsible, or only government cannot be held responsible for the for this groundwater management, right? For the groundwater management, as a community, as a society, we need to go for several aspects, or we need to go for several inputs from our side. Okay, several inputs from our side, so that this area, this groundwater management, right, this groundwater management shall be a successful event. Okay, or it should be a successful thing, right? So a joint management approach combining government administration with active people participation is a promising solution. Okay, now in critically overexploited areas, borewell drilling should be regulated. Okay, the borewell should be regulated, just like the areas where groundwater is very less, or groundwater table is has gone very low. Okay, just like the areas in Vidarbha, the orange cultivated area. Okay, orange cultivation area, or in the Marathwada area where the um, sugarcane is, where the sugarcane is the main crop, right? Because sugarcane needs much water, right? Sugarcane needs very high amount of water. This orange needs very high amount of water, rice needs very high amount of water, right? So these crops, okay, these crops, wherever these crops are getting cultivated, the water level, okay, the groundwater level is highly reduced. Okay, highly reduced, because they have to exploit the groundwater through the wells. Okay, through the wells. So it may be bore well, it may be deep well. Okay, majority nowadays every farmer has a bore well, right? So wherever this the borehole drilling in such areas, okay, in such areas, new boreholes, okay, new boreholes should not be given permission, right? Should not be given permission, or whatever the existing borewells are. Okay, whatever the existing borewells are, that should be regulated, right? That should be regulated. But it is not it is not like load shedding is the option for that, right? Because at some point of time it was an option that just cut the power. Okay, cut the power, so that a farmer cannot run their machines, cannot take out their water pumps. Okay, cannot use the water pump, so that the water level will be increased. Okay, this is not a solution. Okay, this never is a solution. Okay, याला मराठीत म्हणतात रोगापेक्षा भयंकर इलाज. ठीक आहे, हा झाला रोगापेक्षा भयंकर इलाज. सो दिस शुड नॉट बी डन. ओके, artificial recharge measures need to be urgently implemented in such areas. Okay, artificial recharge measures need to be urgently implemented in these areas. We have learned about the artificial recharge techniques, right? We have learned about the artificial recharge techniques. What are those? Which are those? Which technique is suitable to which area, right? We know as a student of geology all these things, right? So these kind of techniques, okay, these kind of artificial recharge measures, okay, these kind of artificial recharge measures should be immediately or urgently implemented in such areas where there are the groundwater tables which are drastically reduced or drastically exploited. Okay, so amongst the various recharge techniques, percolation tank are the least expensive, obviously. Okay, percolation tanks, they can build percolation tank, or several times, just like that Pani Foundation, you might have heard about this Pani Foundation. They have rejuvenated very these lakes in the fields, right? The water cup competition and all they have organized with the aid of Maharashtra government. Okay, so these kind of activities can be done, right? Then many such tanks already exist, but vast majority of these structures have silted up. Okay, silted up, that means it has been these structures are filled with the silt. Okay, they can be, or they should be taken out. Okay, they should be cleaned. Okay, they must be cleaned, and this cleaning will make them reusable. Okay, once you clean the tank, it will be reusable. Okay, promotion of participatory action in rehabilitating tanks for recharge would go a long way in augmenting groundwater supply. So this cleaning, and it will give you the rehabilitation of this tank itself. Okay, and it will ensure a large amount of groundwater supply. Okay, so due to declining water table, the cost of extraction of groundwater has been increasing. Okay, and wells often go dry. This is a very serious problem, right? This is a very serious problem. The cost of extracting water, okay, cost of extracting water is very high. How is it very high? Because once when the water level used to be at shallow level, okay, water table at the shallow level, one pump or just immersing bucket, okay, would be an enough kind of measure to take out water, right? But as the groundwater level is declining, okay, as the groundwater level is declining, what you have to do, you have to employ large capacity pumps. Okay, you have to employ the large capacity of pumps, right? Somewhere there are the groundwater level is so low, okay, so lowered that one pump cannot do anything. Okay, one pump is not even enough. The powerful pumps, okay, one pump is not enough. So to run one pump, you need to apply another pump, right? You need to apply another pump. So one pump fueling another pump. Okay, sometimes third pump should be employed. Okay, third pump is to be employed. Okay, so three pumps, four pumps, these kind of structures are there, this kind of settings are there. And if any of these four or three pumps have encountered with any kind of problem, the farmer needs to evacuate the entire system, right? The farmer needs to evacuate the entire system and repair the pump, and then reinstall all that mechanism, right? Reinstall all that mechanism, and then he will try it, or he will be able to take out water, right? So these kind of problems are there, right? These kind of problems, and this will increase the charge. This will increase the cost, right? As well as the electricity cost, right? The electricity cost, nowadays the solar pumps are being used, right? The solar pumps are being used, but the solar panels, they are useful in summer. Okay, the solar panels are useful in summer. In the rainy season, or in such times when the sunlight is not that much bright, they cannot be used, or they cannot run with their full capacity, right? This can be a problem, right? This can be a problem, right? Hence the cost of taking out water is increasing day by day, okay, with decreasing the depth, right? With decreasing depth or with lowering of the depth, the cost of extraction of groundwater is being increasing over time, okay. And wells often go dry because groundwater is limited, right? Groundwater is a limited commodity. It is a commodity, right? It is a commodity. It is basically not a resource, okay. It is not, I should not say that it is a resource. Obviously, it is a resource. But when we are talking economic aspect of this, right? Economic aspect of groundwater is a commodity, right? Groundwater is a commodity. It can be sold, it can be bought, right? So it is a commodity, right? And it is a very, very expensive commodity nowadays, right? So this poses serious financial burden on farmers. Okay, so special programs need to be designed to support these farmers. Okay, role of government will have to switch from the controller of groundwater development to that the facilitator of equitable and sustainable development. Right? All these things need to be done for the groundwater management. Okay, all these things need to be done for the groundwater management. Okay, got this. So, what is the need of groundwater management? Okay, this was all about the need of groundwater management. This part we have done watershed management. Okay, now the important part is the rainwater harvesting. Okay, important part is this rainwater harvesting. Now, what is this rainwater harvesting? Is that the process to capture and store rainfall for its efficient utilization and conservation to control its runoff, evaporation, and seepage. Right. So, whatever rainfall our state or the country has receiving, okay, we receive enough amount of rainfall, okay, enough amount of rainfall, and this amount of rainfall or this amount of water should be collected, okay. This should be collected. This should not be allowed to simply run off, okay. This should be collected either on the rooftop or in a community level, right, in a tanks like this. And this water, okay, this water should be allowed, okay, should be allowed to percolate, okay. This should be allowed to percolate where inside the earth, okay. This should be allowed to percolate inside the earth, right? Even, okay, in why do we need this rainwater harvesting? It increases water availability, obvious, okay. This is very much obvious that it will increase the water availability. Water will available, more water will available as more and more water will be percolated, right? It checks the declining water table. Declining water table will be recharged, right? Declining water table will be recharged. You might have seen this phenomenon if you're if you have this uh, dug wells in your homes, okay, dug wells in your homes. See the water level, the increase of water level in the rainy season, right? The water level increases in the rainy season. Some of the wells are there are some wells through which you can just simply put the bucket even without the rope, okay, even without the rope. In my house itself, okay, I have in my house the uh, dug well, okay, dug well. It goes dry in summer, almost goes, not exactly, but it almost goes dry in summer. But in the case of rainy season, we can just simply put out water by simply taking out these through the bucket, right? We don't even need the this rope, okay. We don't need the rope. Just open this shutter, okay. We have this shutter on this well. So I just open the shutter, put the bucket inside, and take out water. So this is the fluctuation, right? This is the fluctuation. So this declining water table, okay, the water table declines in the summer, right? Water table declines in the summer, but it increases in the in the rainy season, right? Why is it so? Because the water gets saturated or water gets percolated inside the earth, okay, inside the aquifer, right? It is environmental friendly, obviously. It is environmental friendly, okay. You need not to go for some high end things, right? It does not mixes chemicals with the chemicals in the uh, groundwater, right? It improves the quality of groundwater through dilution mainly of fluoride, nitrate, and salinity. Now, this is important thing, right? This is an important thing, that groundwater quality increases, right? Groundwater quality increases. Sometimes there is salt water intrusion. Okay, there is something called as salt water intrusion. Geiben-Herzberg relation is based on this salt water intrusion. Okay, so what is this saltwater intrusion? Where whenever there is a freshwater aquifer, okay, freshwater aquifer, and besides freshwater aquifer or nearby to the freshwater aquifer, if there is saline water aquifer, okay, or saltwater aquifer, the salt water gets intruded inside the freshwater aquifer, and it contaminates the freshwater, right? Contaminates the freshwater. If we so contamination in the form of increase in salt content, right? Increase in the salt content. If the groundwater is getting recharged with the fresh water again, right? If such content or such contaminated groundwater is treated with the fresh water, what will happen? This salt content will go lowered. Okay, this salt content will be lowered and the groundwater quality will be increased. Okay, the groundwater quality will be improved, right? So they through dilution, it will, this process is called as dilution. So fluoride, nitrate, and salinity, these processes, okay, or these things will be reduced drastically, right? It prevents soil erosion and flooding, especially in the urban areas. Okay, because for rainwater harvesting we need to check this groundwater flow. Okay, not the rainwater flow, we need to check the rainwater flow. Okay, and as we are checking the rainwater flow, it will it will reduce the soil erosion. Okay, it will reduce the soil erosion, and also it will be easier for us to stop flooding. Okay, these are some of the benefits of rainwater harvesting. Okay, these are some of the benefits of rainwater harvesting. This can be a potential question. Which of the following are the benefits of rainwater harvesting? Okay, this was asked in GSD, that your 2013 paper. Okay. Now, uh, has anybody visited Karla Caves?
Yes, sir.
Karla Caves in rainy season.
Lonavala, na? Yes, sir.
Lonavala, correct. Not Lonavala, near Thane and Mumbai. Somewhere like that. Karle and Elephanta. Elephanta is in Arabian Sea. So if you visit Karle Caves or Karla Caves, whatever, okay, Karla Cave or Karle Cave, you can observe that it is situated in massive basalt basically. Okay, it is situated in massive basalt, but you will see some interesting structures there. Okay, you will see interesting structures. The basalt is carved like this. Okay, the basalt is carved like this. Okay, there are some ridges. Okay, some ridges and grooves, right? Some depressions are there, and these depressions end in such tanks. Okay, they end in such tanks. So one tank is there, just like one, this is one tank, and in the lower level there is another tank, there is another tank, and so on, right? So on. These are very smaller tanks. Okay, these are very smaller tanks, not much larger tanks, but these are the smaller structures, these are smaller depressions. For what they were used for? They were used for uh, rainwater harvesting uh, rainwater harvesting activities. Okay, the people living there, basically the Buddhist monks. Okay, the Buddhist monks who used the Karla caves as their dwelling place. Okay, what they used to do, they used to dig out some of these pits. Okay, the pits like this. Okay, and whenever rainwater used to come, okay, whenever rainwater used to come from these ridges, the water used to get collected here first in the first stage. Then when it will be overflowed, it will be collected into second. When the second one is overflowed, it will be in the third, and so on, right? And so on. So this is one of the technique Okay, this is one of the rainwater harvesting techniques. These people, okay, those people in the historic time they have used. Okay, they have used. So rainwater harvesting is not a new technique. Okay, this is not a new technique, or this is not something which we have invented. Okay, this is a technique which is traditionally known. Okay, which is traditionally known and traditionally been used. We have forgotten. Okay, we have forgot it, and we have let go the rainwater harvesting and all by constructing this cement structures. Okay, we have constructed larger cement structures. We have just covered the soil by cement, by tar, by concrete, right? And we have just sealed the pore. We have just sealed the pore spaces of the soil, and we let go the this rainwater towards the rivers or towards the larger outlets, right? So in the ancient days, people were familiar with the method of conservation of rainwater and had practiced them with success, which I have given you the example. One more example is in the Khandagiri. Okay, Khandagiri, Odisha. Okay, if anybody has visited Bhubaneswar, okay, Khandagiri and Udaygiri, two caves are there, okay, opposite to each other. Okay, Khandagiri and Udaygiri, two caves are there, and both these two caves has this water conservation structure. Okay, both these two caves have the water conservation structures. Okay, so this is an ancient knowledge. Okay, this is the ancient knowledge, right? Different method of rainwater harvesting were developed to suit the geographical and meteorological conditions of the regions of various parts of the country. So wherever these uh, meteorological pattern is there, like in Maharashtra. Okay, if you are talking about Maharashtra, so in Maharashtra we have larger rainfalls. Okay, we have larger rainfall, but due to having basalt, okay, the massive and compact basalt, we cannot store much water. Okay, it cannot store water. It will store water only in the interstices. It will store water in only in the fractures in the vesicles, right? So as we knew, okay, as we knew that the geological condition, geographical condition of the area is like this, it cannot sustain or it cannot hold much water. What will it do? What will they do? They have constructed the pits, right? They have constructed the pits, artificial pits, because rocks naturally cannot contain water or cannot hold water naturally. Okay, so we need to give them some artificial artificial aid to store water. Okay, because water is a basic necessity. Okay. Traditional rainwater harvesting, which is still prevalent in rural areas, is done by using surface storage bodies like lakes, ponds, irrigation tanks, temple tanks, etc. Okay, in earlier days, okay, in earlier days or in larger temples, okay, especially in the South Indian temples, okay, especially in South Indian temples, it is a striking feature. Okay, it is a striking feature that if suppose this is a temple complex, okay, if suppose this is a temple complex, this is a gate which is called as Gopuram. Okay, this gate is called as Gopur or Gopuram, and as you enter the Gopuram, in either of this side, okay, either of the side of this Gopuram, there is a tank. Okay, there is a tank, and here in the end, okay, here in the end there is Garbhagruha. Okay, this is Garbhagruha, right? So Garbhagruha means where the main deity is placed. Okay, but this is a striking feature of majority of the South Indian temples. Okay, majority of the Dravidian temples is they have tanks inside their temples. Okay, they had tanks inside the temples. Okay, Nagar style temples, they lack the tanks. Okay, Nagar style temples, they don't have the tanks. Why is it so? I hope you know this Nagar style of architecture and Dravida style. This is all about the temple architecture. Okay, and be prepared for this. MPSC can ask anything in interview. Yes. Why is it so that Nagara style temples don't have tanks and Dravidian temples have tanks? Why is it so? No idea. Nagar style temples, okay, the Nagar style temples are constructed in the northern part of the country. Okay, they have been constructed into the northern part of the country. That means the Uttar Pradesh, then Bihar, Madhya Pradesh, okay, Gujarat area, okay, these area, the northern part of this, majority of the northern part of the country, which is endowed with larger rivers. Okay, it is endowed with larger rivers and it has ample amount of water. Okay, it had ample amount of water so that they need not to store water. Okay, they need not to store water. Go to this any of the village near about the near the Ganga plains. Okay, go to Kashi Vishwanath. Okay, that temples, these temples on Ganga, right, on the banks of Ganga. Why would they need why would they need the tank? They had mighty Ganga flowing besides them, right? So they did not require to store water. Okay, they did not require to store water in the Nagar style. Okay, in the Nagar style. But that is the striking difference between Nagar and Dravidian. In the Dravidian side, which is in the South India, okay, majority of the temples, okay, majority of the South Indian temples are made or constructed in such areas which are prone to droughts. Okay, which are prone to droughts, or which had lack of rivers, or which had less rainfall. Okay, so they needed to store water. Okay, they needed to store water and hence they had the tanks. Okay, this temple tanks, right? So in villages, even if you go to the villages, you will find the lakes. If in your villages, if anybody is having a field or farm, go to your farm, you'll find a large lake inside your farm, right? Ponds might be there, irrigation tanks might be there for irrigation purposes, right? Like Kul, which is divergent channel irrigation system, full irrigation system which carries water from glacier to villages. It is practiced in Spiti area of Himachal Pradesh. Okay, this is one of the examples, right? In the arid regions of Rajasthan, rainwater harvesting structures locally known as Kund. Okay, it is known as Kund, or you might have heard about this Baulis. Okay, Baulis or Baudi, to the well, this stepped well. Okay, the stepped well, right? This will be called this would be called as Baulis. Okay, so these are the techniques. Okay, these were the techniques. These were the ancient techniques which are still in use, right? Which are still in use and which are still in perfect condition. Okay, these techniques are still in perfect conditions, right? These are basically the community participation. Okay, these are the community participation in groundwater recharge or groundwater management, right? Now, water management in independent India. Okay. So India attained its independence from British rule in August 1947. Okay, with independence came partition. So just leave that. So bulk of the public irrigation network that British had created ended up in Pakistan. Okay, why is it so? Why is it so? Because the productive part of the Punjab area, okay, productive part of Punjab area has gone to the Pakistan. Okay, it has gone to Pakistan, and less area is remained in India. Okay, and hence Britishers have created the public irrigation networks. Okay, they had created the public irrigation networks, and that irrigation networks and that irrigated land went to Pakistan. Okay, so government of India's main aim after independence was to accelerate development and address the regional disparity of investment, as it was facing serious food grain shortage and rapid rate of population increase. Right. So what they did, or what did they do? They started larger irrigation programs. Okay, they started large irrigation program or large scale irrigation program. Okay, so huge investment in large scale irrigation project was considered to be the best option to redress all these problems. Okay, this came from the 5-year plan. Okay, 5-year plan. Earlier there used to be planning commission. Okay, there used to be planning commission. In 2015, the planning commission was demolished and Niti Ayog has established. Right. Basically, the work is same. Okay, basically work is same. Just basic structure has been changed. Okay. Then investment in the large scale surface irrigation was targeted under first two plans, and giant projects like Bhakranangal at the Damodar Valley and the Hirakud projects were undertaken during that time. Okay, remember this. Remember this. Bhakranangal, Damodar Valley, and Hirakud, they were constructed in first two 5-year plans. Plan 5-year plan 1, first 5-year plan, and second 5-year plan. Okay. So 5-year plan started from 1951. So first 5-year plan 1951 and second 5-year plan 1956. Right. Minor irrigation projects did receive some attention, but the importance was given to the major and medium. Right. Early post-independence area was taking pride in launching vast new projects and large dams seen as the modern temple of modern India, keeping in view the vision of Pandit Jawaharlal Nehru. Okay, with a zeal of commitment to social progress, was new multipurpose dams, multipurpose irrigation project as the matter of pride in the early post-independence year. Okay, but it is like many of the projects have started but never completed. Okay, many of the projects like they started but never completed. Right. For example, this which dam? Sardar Sarovar Dam. Okay, Sardar Sarovar Dam is it started its construction in 1955 and it was finally inaugurated in 2016 or 17. Right, so it took large amount of time. It took large amount of time. Right now, why they failed and all, we need not to go in all these details. Okay, we are most concerned about this community based management. Okay, we are most concerned about this community based management. What is community based management and why is it that important? Okay, because technically what we can do in technique or in technology, what we can do, we can go for rainwater harvesting, right? We can go for rainwater harvesting or we can go for artificial recharge. Okay. What else we can do? Okay. But artificial recharge and rainwater harvesting can be done. Okay, rainwater harvesting and artificial recharge can be done on the basis of community based management, right? On the basis of community based management, right? So in 1980, the attempts were made to bring about reform in the management practices of irrigation department through the World Bank supported National Water Management Program or project. Okay, so it has three distinct phases. The concept was limited to farmers' participation through their representatives in project management committees, but not successful. Obviously, these kind of committees are never successful. Okay, in the latter parts, farmers' organizations such as Chuck committees were formed, but many of these committees remained only on paper and became dysfunctional. Okay, the concept of creating farmers' organization and of system turnover was adopted through World Bank funded Water Resource Consolidation Project. Okay, these are some of the projects which were launched by government just to have this community participation. Okay, to have the community participation in the uh, groundwater management, but nothing was nothing was worth. Okay, nothing was worth. Okay. Since independence, the expansion of irrigated area by canals has been significant from 8.3 million hectares to 18 million hectares in 1999. Okay. In regard to community participation in irrigation management, Government of India has also launched National Water Policy in 1987, putting emphasis on farmers' participation in the management of irrigation system, especially in water distribution and collection of water recharge. Okay. Now this National Water Policy 2002. Okay, this National Water Policy of 2002 emphasizes on participatory approach for the management of water by having cooperation between various government agencies and other stakeholders, including women participation when in various aspects of planning, design, development, and management of the water resources. Now, What do we need basically? We don't need any committees. We don't need any high level committees for to have this uh, water management. Okay, groundwater management. What do we need? The farmers should come forward. Okay, the farmer come should forward. The normal people like us, they should come forward and they should work for the water management problem, right? So this national water policy says that there should be a participatory approach. The farmers and the women, they should participate along with the government agencies, right? The government agencies like CGWB, like GSDA. Okay, these government agencies should work in accordance with the farmers, in accordance with the women, to make these kind of policies or these kind of practices successful. Okay, involving the local bodies such as municipalities or gram panchayats in the operation. Maintenance and management of water infrastructure was done in keeping in view eventual transfer of management rights to the user groups. That means there is something which is called as BOT. Okay, BOT means build, operate, and transfer. Okay, build, operate, transfer. That means government will build something like any kind of service. Okay, they have given you the service like uh, government has constructed this pit. Okay, government has constructed this pit, the recharge pit. Okay, government has constructed the recharge pit. They have told you, or they have train you how to use the recharge pit, how to use this kind of structure to recharge your areas. Okay, so they have built it, operated it for several times, and then transferred it to the user group. Okay, transferred it to the user. That means if I am the end user, okay, if I am the end user, this will belong to me finally. Okay, this will belong to me. Obviously it will be the property of government. Okay, it will be property of government, but it will be now my responsibility. Okay, it will be now my responsibility to make it or to operate it successfully, right? So the management rights, so the operational rights should be given to me, because I am the end user. It is me who will be using all the water, right? It will be me who will be using all the water which have been recharged, right? So right to every right to take any decision about that structure should be given to me, right? It should be given to me, and this is what government has done. Okay, post-independence era has seen impressive increase in the irrigated areas by large in surface systems under state governments. Okay, under the state government basically because it comes under the purview of state list. Then this micro watershed based approach to natural resource management has been hampered due to compartmentalization of various government programs. So that is just leave it. Watershed project approaches have evolved from highly technocratic, large-scale top-down approach to greater local participation, use of local technologies, which resulted in better performance in terms of conservation and productivity. Okay. Now, there are several examples. Okay, three extremely successful village-level projects initiated in 1970s. That is Sukho Majri, राळेगाव सिद्धि, राळेगण सिद्धि, or Pani Panchayat. Okay, what is Pani Panchayat? Okay, which focused on link between soil conservation and water harvesting, are seen as having modern roots of the century-old assortments of soil and water conservation in India. Okay, so in order to replicate the success of these three projects, several large-scale projects were started. A significant step for participatory and decentralized forms decision making and fund allocation was started in the comprehensive common guideline, which was evolved for all programs, right? In the approaches of Sukho Majri, Radegaon Siddhi, and Pani Panchayat. Okay, but it is like these are just the examples. Okay, these are just the examples, and no any further project. Okay, no any further project could take this kind of uh, what I can say, this kind of success. Okay, so the conclusion basically, okay, conclusion basically is that water management is a tricky affair in India. Okay, tricky affair in India due to socio-economic and political and ecological reasons, because India is such a diverse country. Okay, India is such a diverse country. Even if you are talking about Maharashtra, Maharashtra has the basaltic terrain, as well as we have the Gondwana terrain. We have these Archean terrain. Okay, so we have different kind of rocks, right? We have different types of rocks, and due to this, okay, due to this, what we are doing is that we cannot store large amount of water in any one area. Okay, just like a few years back, in Latur, okay, in Latur, water used to be, or water needed to be provided from train. Okay, if you have heard this news, okay, water had to be supplied through the railway. Okay, come at least 5 to 10 railways, okay, at least 5 to 10 railways, they provided water to the Latur district. Okay, it was that scarce. Okay, it was that problem, right? So these are some of the problems. Okay, these are the problems, and these problems can be addressed, right? These problems can be addressed through the community partnership only. Okay, through the community partnership only. Only with the community partnership, these problems can be solved. Okay, these problems can be solved, and these problems can be addressed, right? So technical aspect is the rainwater harvesting and artificial recharge. Okay, technical aspect is rainwater harvesting, artificial recharge, and everything else is a social aspect. Okay, even the rainwater harvesting and artificial recharge is a social aspect of groundwater management. And what is the need of groundwater management? To increase the water table, to have improve the quality of groundwater, right? All these things. Okay, what is, so this is the groundwater management technical and social aspects. You have any questions in this? Okay, if not, I'll move forward to the next topic, and that is groundwater provinces in Maharashtra. Okay, the groundwater provinces in Maharashtra. Okay, is my screen visible?
Yes, sir.
Yes, sir.
So we have gone through the stratigraphy of Maharashtra, right? We have gone through the stratigraphy of Maharashtra for say for 3 or 4 classes. Okay, so you know the stratigraphic framework of Maharashtra, right? You know the stratigraphic framework of Maharashtra. Now we have to look for this stratigraphic framework in the purview, or in the light of hydrogeology, right? So in the stratigraphy of area, stratigraphy of Maharashtra, majority of the Maharashtra state has been covered by basalt, right? Majority of Maharashtra state has been covered by Deccan basalt, right? After that, we have some Archeans, we have some Gondwanas, we have some intertraps, infratraps, all these things, right? So geologically, most important rock type of Maharashtra state is basaltic lava flows, the Deccan traps. Okay, the Deccan traps. Okay, you need not to know, or you need not to remember these things. Okay, these areas and all. Okay, you can remember this 81.2 or more or less 82, 83%, right? It is found in all districts of the states, expanding excepting Bhandara and Gadchiroli. Only the 2 districts are there. So this can be a relevant relevant information for your exam. Okay. Other major geological formations are Archeans, the Precambrian formations, then Gondwanas, alluvium. Okay. The various formations are grouped under 3 major hydrogeological groups. Okay. 3 major hydrogeological groups are there. Okay. That is unconsolidated, semi-consolidated, and consolidated. unconsolidated, semi-consolidated, and consolidated. Right? 9 different types of hydrogeological subgroups based on geological age and hydrogeological characters. So I have a table here. Okay, I have a table here. This table is a very important table. It will serve your two purposes. Okay, it will serve your two purposes. First, the groundwater provinces of Maharashtra. Other, the stratigraphy of Maharashtra. Right? Learn this table. Okay, learn this table. It will give you the insight of stratigraphy of Maharashtra completely. Right from it begins from here, Archeans. Okay, it begins from Archeans, and then see all this given, all are given there. Right, Dharwad, then iron ore series, then Sausar. Okay, Archean complex, then Vindhyan, Kadapa, Kaladgis, then Deccan traps. Okay, then Gondwanas, infra traps, bark bed, lamitas, then coastal sedimentaries, laterites, then river alluvium, Tapi Purna, and other rivers, and some beach deposits. Okay, so the entire stratigraphy of Maharashtra, okay, entire stratigraphy of Maharashtra with their formations here, stratigraphic unit, right? Here is the stratigraphic unit. This is the geological age of these units. Then the rock formations are there, and occurrence and hydrological characteristics. So here in the district, which kind of deposit is present, right? Just like here, Gondwanas present in Gadchiroli, Amravati, Chandrapur, Nagpur, and Yavatmal, right? Then they possess moderate to good aquifers. Sandstones are jointed and fractured and possess secondary porosity. That's it, right? So it will help you, right? It will help you in last minute revision. Okay, it will help you in the last minute revision. That just learn this table. Okay, learn this one table. You will have the hand on stratigraphy of Maharashtra as well as on the groundwater provinces of Maharashtra. Right? Now this table will be available in the app. Okay, this entire document will be available in the app, so you can read it. Right. Let us go into details of this. The first is unconsolidated group. Okay, the first one is the unconsolidated group. Now this unconsolidated group, okay, this unconsolidated group, it carries or it covers the beach deposits or coastal sands. Okay, so all along the Konkan coast, a narrow strip of alluvium where locally extensive assumes importance as moderate groundwater reservoirs. Okay, basically unconsolidated. What does it mean? Unconsolidated. Unconsolidated means which has not been lithified, right? Which has not been lithified. So in Maharashtra or in the stratigraphy of Maharashtra, only the river alluvium and beaches. These are the formations or these are the areas which are unconsolidated, right? Which are unconsolidated. That means they can be they can be separated into pieces, right? They can be separated into each and every sand grain, right? So beach deposits are very obviously unconsolidated group. Then river alluvium, other than in the fault plains, okay, other than in the fault basin. Okay. The fluvial deposits occur along the river courses and locally significant hydrogeological units, right? This generally comprises of silt, clays, gravel, and occasionally cobble beds. The coarser granular strata such as sand, gravels, pebble beds, when occurring below water table, form productive aquifers, right? So river alluvium is a unconsolidated group. Right? Then river alluvium in Purna Tapi fault basin. Right? Tapi Purna or Purna Tapi, whatever you want to call it. Okay. This is a major alluvial deposit of the state. Okay. This is the major alluvial deposit of the state. Right. Where do this occur? Amravati, Akola, Buldhana, Jalgaon, and Dhule district. Okay. So these are the 5 districts. It covers the 5 districts. Right. Alluvium comprises a bed of clay and silt with lenses of coarse sand, gravel, and boulders. The upper layers of alluvium down to the depth of about 80 meter contain 2 to 4 permeable granular zones. Right. The older alluvium has poor ground water potential. Okay. So this is the unconsolidated. Okay. This is the unconsolidated group. Now, second one is the semi-consolidated. Okay, this semi-consolidated group. Now, in the semi-consolidated group, there are majoritarily sedimentary rocks. Okay, majority the sedimentary rocks. So see here, the coastal sedimentaries and laterites, these are nothing but the sedimentary rocks. Then infratrapians are sedimentary rocks, right? Then Gondwanas, obviously sedimentary rocks, right? So these majority of the sedimentary rocks are semi-consolidated, means they have been lithified. Okay, the sediments have been lithified, but they retain good groundwater potential. Okay, they retain good groundwater potential and they retain good amount of groundwater within them. Right. So along the Konkan coast and below the beaches, deposits with few exposures of semi-consolidated calcareous sandstone occur, which are coarse-grained and gritty, belonging to Myopliocene age. Right. You need not to go into these details, Myopliocene and all. Right. As per I can visualize by observing the paper. Okay. The forms it forms the local hydrogeological unit. This is one hydrogeological unit. Okay, which yields good discharge of two dug wells. Okay. Konkan coast is also characterized by thick profile of laterite, which is highly porous and permeable, yielding substantial quality or substantial quantity of groundwater. Then infratrapians, the bark beds occurring in the Dhule district close to Narmada basin and lametas occurring in small patches in Nagpur and Amravati district of upper Cretaceous age and occur below Deccan traps. Okay. These deposits have minor occurrences and limited thickness and yields poor to fairly good discharge. Okay, you can see this. These bark beds, these lametta beds, these are essentially the sedimentary beds. Okay, these are essentially sedimentary beds and they yield proper discharge in the dug wells. Right. Gondwanas, it has sandstones. Okay, especially the eastern part. The main rock is coarse-grained feldspathic and ferruginous sandstones having good primary porosity. They form moderate to good aquifer. These are jointed, fractured, and faulted, imparting the secondary porosity. So Gondwanas, wherever the Gondwanas are present, they will form good aquifer. Okay, they will form the good aquifer. And then comes the consolidated group. Okay, then it will come the consolidated group, and that this consolidated group is Deccan traps. Okay, Deccan traps. Obviously, this will be consolidated, right? This will be consolidated because it does not have the space, does not have the voids to percolate water, right? It does not have the voids to percolate the water. It has only the secondary porosity. It does not have the primary porosity, right? Primary porosity is which is formed during the formation of the rock. It has the secondary porosity. That means water can only be percolated. Water can only be stored in the fractures or in the void spaces. Okay. So most important hydrogeological formations, it forms the most important hydrological formations or hydrogeological formations because of this number. 82% of the geographical area of the state is covered by the Deccan Traps. Okay. This can be broadly subdivided into vesicular basalt, then massive basalt, amygdaloidal basalt, jointed or fractured basalt, or brecciated basalt. Okay. The individual lava flows varies greatly in thickness from few meters to as much as 50 meters. The cumulative thickness is maximum in the western part of the state. Okay, western part of the state near Sahyadris. Okay, near the Sahyadri, and completely thinned out to the east near Nagpur. Okay, and after Nagpur, no Deccan Trap is there. Okay, after Nagpur, there is no Deccan Trap, and hence Bhandara does not have any exposure of Deccan Traps. Bhandara and Gadchiroli, these two districts. Okay, the various types, it has been described well in this table. Okay, now you can see this in the table. The classification of Deccan Trap is given. Okay, the classification of Deccan Trap is given with respect to their geographical location. Okay, with respect to their geographical location. So you can see this. There is a description where the bauxite is there, where the ash beds are there, where dikes are there, and where do they actually lie in the geography of Maharashtra. Right. Then comes the Precambrian sedimentaries like Kaladagi series. Okay, the Kaladagi series occur as the water-bearing horizons in the part of Ratnagiri district in Konkan region. Groundwater occurs under unconfined conditions in the weathered mantle and along the joints in sandstone, shale, and limestone. Right. This is the lithology which is present with the Precambrian sediments. Okay. These Precambrian sediments belonging to Kadapa and Vindhyan is equivalent occur in small areas of Chandrapur, Yavatmal, and Gadchiroli districts of Vidarbha. Okay. These formations have negligible primary porosity. Obviously, majority of these are compact sandstones or metamorphosed. Like in the Kadappas, we have this quartzite. Okay, in Vindhyans, you have massive sandstones, massive limestone. Okay, water occurs in fractures in solutions cavities under unconfined and semi-confined conditions. Right. So this is the hydrogeology of pre-Cambrian sediments and the crystalline, that is the basement. Okay, the crystallines or the basements. The crystalline formations of Archean and lower Precambrian age form dominant water-bearing horizons in Bhandara, Gadchiroli, parts of Nagpur and Nanded district, and in Konkan region, Ratnagiri, in the coastal region of Ratnagiri and Sindhudurg. Okay, wherever there is a crystalline basement, that is a Precambrian or Archean basement. Okay, Precambrian or Archean basement that will contain this crystalline, that is the consolidated formation. Okay, that is the consolidated formation. Okay. So groundwaters in these formations are generally occurs under unconfined conditions in controlled by degree of weathering, fracturing, and jointing. Wherever these rocks are fractured, joint, or they are weathered, then and only then it will contain water. Inherently, they don't have any tendency. Okay, they do not have any tendency to store water. Right? Majoritarily, these rocks are metamorphic. Okay, majoritarily these rocks are metamorphic, and hence they don't have that much tendency to store water or to hold water. Right. So these are the three zones or three provinces or the three hydrogeological provinces in Maharashtra. Okay, three hydrogeological provinces in Maharashtra. Takeaway from this class or from this document is this table. Okay, remember this table, learn this table. Almost 5 to 6 questions can be framed from this this only table. Okay, 5 to 6 questions or even 10 questions can be framed from this table. Okay, they can frame the question from stratigraphy, they can frame the question from hydrogeology. Even they can ask about the age for individual formation, or they can they can ask for the lithology of any individual formation. Right. So remember this table. Right. Remember this table well, so that you can be in a position to answer the questions in hydrogeology as well as in the stratigraphy. Right. Anything to ask in this? Anything to ask in this, or shall I move forward? Okay, so let us take last topic for the day, and that is groundwater legislation. Okay. The groundwater legislation. Now, what is this groundwater legislation? Okay, the groundwater legislation is legal framework according to the groundwater usage. Okay, the legal framework for the groundwater usage. Okay, so it was the year 1993. Okay, it was the year 1993 when Maharashtra government has first framed the groundwater law. Okay, the groundwater management law. Okay, okay, the Groundwater Management Act 1993. Right, this was the first act, and this was one of the very first um, efforts in the country to know or to have the sustainable development about groundwater. Okay, and then in 2009, okay, in the 2009, the new act was passed. Okay, new act was passed, and that has been called as Maharashtra Groundwater Development and Management Act 2009. Okay, this act was called Maharashtra Groundwater Development and Management Act 2009. 2009. So it was enacted in 2009 and it is still in function. Okay. Now, so this act is enacted to further facilitate and ensure sustainable, equitable, and adequate supply of groundwater. Okay, of groundwater of prescribed quality. You can be asked the aim of the act. Okay, the aim of the act. What this act aims about. Okay, what this act aims about. So this act aims about to sustainable, equitable, and adequate supply of groundwater of prescribed quality. That means you must get water. Okay, you must get water. You must get proper water. You must get adequate water, but you must get quality water. Okay, it is not like any water can be supplied. Right, any water cannot be supplied. Okay, and these all are related with drinking water and as well as the irrigation. Right, drinking water as well as irrigation water. Right. For various category of users through supply and demand management measures, protecting public drinking water sources. So protection of public drinking water sources is one of the aim of this act. Okay, right. So you can be asked about the definition. This is the aim or the definition of the act, and another aim of this is protecting the public drinking water sources, just like rivers, just like ponds, just like lakes. The state groundwater authority and district level authorities shall be established to manage and to regulate with community participation and the exploitation of groundwater within the state of Maharashtra. Right? To manage, there should be a state groundwater authority. In Maharashtra, we have GSDA. Okay, in Maharashtra, we have GSDA, Groundwater Survey and Development Agency. And district level authorities are nothing but these municipalities. Okay, municipalities, they have their own departments of groundwater, right? These to be established to manage and regulate. Okay, to manage and regulate with the community participation. The community participation is very important. Okay, community should participate, we should participate in these measures. Okay, these measures which are being taken by the government. Okay, to exploitation of groundwater within the state of Maharashtra. So in the state of Maharashtra, there should not be large amount of exploitation of water. Okay, so what state shall do? Okay, the state authority, what a state authority shall do? The state authority shall ensure the registration of all the owners of wells in both the notified and non-notified areas of the state, where the notified areas and non-notified areas are there. Whomsoever is the owner of the well, okay, whomsoever is the owner of the well, it should be registered with the government. Okay, that person should be registered to the government. Take necessary measures to the protection and preservation of water quality of drinking water source from where the water is being supplied to the municipal area or to the villages, right? At say in Nagpur district or Nagpur city. Okay, the water is coming from Kanhan river. Okay, water is coming from the Kanhan river. So it is the duty or it is the obligation of state authority to keep the Kanhan river clean, right? To keep the Kanhan river clean so that the source is clean. Okay, if the source is clean, then the supply will also be of clean water, right? So this is the protection and preservation of water quality of the drinking water source. So the source should be protected. The source should be preserved. The water quality at the source should be preserved so that the supply should be adequate and supply should be proper. Right. To identify the recharge worthy areas in the state and issue necessary guidelines for rainwater harvesting and to recharge groundwater. This is important that state authority must identify the areas. Okay, must identify the areas where they can go for artificial recharge. Okay, where they can go for rainwater harvesting. Okay, and the necessary steps to be taken, right? Necessary steps to be taken if there need to be if there needs the construction of a dam, if there needs to be construction of a bandhara or a recharge pit or anything like that, any structure like that. Okay, these structures should be constructed, right? These structures should be constructed. Community participation should be allowed. Okay, all these things must be done, and these are the obligations to the state authority. Okay, the state government shall assign the responsibility of the State Watershed Management Council to the State Water Council constituted under Section 16 of the Water Resources Act. Okay, under the Water Resources Act. This Water Resources Act is by the central government. Okay, this is the model act basically. Okay, so the responsibility of state watershed management to the State Water Council. Okay, this should be given. This responsibility should be given to the State Water Council. Okay, and the State Water Council and State Watershed Management Council shall approve the integrated watershed development and management plan for the entire state and shall ensure its integration with the state water plan. So there are these two agencies. Okay, these two agencies at the government level, and these agencies will, or these agencies shall integrate together. They shall integrate together, and they must enact themselves, and they must take steps for the integrated watershed management and development. Okay, watershed management and development. Okay, so the act further makes provision for groundwater use plan and crop plan. That means how much groundwater should be used or how the groundwater should be used for the crops. Prohibition of drilling of deep water wells. Okay, deep wells should not be dug or constructed. Withdrawal of groundwater from existing deep well. Okay, if larger deep wells are there, withdrawal should be prohibited. Okay, and provision of levy of cess means the tax basically. Okay, that 0.5%, 1% tax. Okay, these taxes can be taken from these people who are withdrawing water from deep wells. Okay, registration of drilling agencies, whomsoever is drilling. Okay, whomsoever is drilling the wells, these agencies should be registered with the government. Okay, safety measures for the wells should be constructed with with safety. Okay, declaration of water scarcity area and protection of drinking water sources during the water scarcity. Whichever area has the water scarcity, just like I have given you the example of Latur. Okay, Latur. So Latur has been declared water scarcity area under this act. Okay, under this act, right? So it was that Latur city or the Latur district was declared water scarce area under this act. Okay, and protection of drinking water sources during the water scarcity. If you Google the images, okay, you just Google the images of water scarcity and okay, the water scarcity and supply of water to Latur by train. Okay, supply of water to Latur by train. Just Google the images. You will see policemen. Okay, you will see the policemen guarding the train. Okay, policemen guarding the train when the train was getting emptied in the wells. Okay, the train was getting emptied in the wells, and the policemen, the commandos were actually guarding. Section 144 was employed, that is curfew basically. It was employed in the city so that nobody should come near the train, and there should not be any mishap, right? There should not be any mishap. So this should be protection. Okay, this protection should be given. Such kind of protection should be given to the groundwater. Okay, the groundwater under this act, right? So this is Groundwater Management Act 2009. Okay, so this is all about the groundwater legislation. Okay, so we'll stop here for today.